Good afternoon, matriculants. Welcome back after a very long holiday and welcome to this afternoon's mathematics session on calculus graphs. Let's have a look at the important facts, things that you need to remember before we can start drawing any graphs. First thing, how do we sketch a cubic graph? In basic form, there are just a few facts that we need to remember. I need the y-cut, I need the x-intercept or the x-cut, and for that I need the factor theorem. We're going to calculate the turning point, and for that we say the derivative equals naught. And if I have those pieces of information, I can sketch the graph. Sounds easy, eh? Point of inflection is important. So how do I find that? Important things to remember, that the point of inflection is the second derivative. The second derivative of the function must be equal to naught. Once you have that, I substitute x into the original equation and voila, I have the coordinates of the point of inflection. Lastly, they very often ask us for the equation of the tangent, and in order to determine the equation of the tangent, it is a line, a tangent, so therefore I substitute x, the value that they are going to give me, into the derivative in order to find m. Once I have m, I can then use that value x to find the y coordinate, and I use that point to find the value of c, and the equation of the tangent becomes y equals mx plus c. So in short, we are going to sketch the graph. The point of inflection is important, as well as the equation of the tangent. I see quite a number of Sinanjonga that joined us. Allo is with us. Manenberg, Sek, and Peakview joined us already at this point in time. Welcome to all of you. So let's start. On page 15, I'm going to start with question example 1. Right. I want you all to write down the equation of that example. Write down the equation. F of x equals x cubed minus 5x plus 3. The first question. Show that x minus 1 is a factor of f of x. Oh, factor? What does that mean? Oh yeah, I remember. If something is a factor, then the remainder must be equal to 0. So, it is obvious that I'm going to make use of the factor theorem to show that. And we also know if this is true, then my answer must be 0. So, let's start. I've got mine here in front of me. My equation is written down. F of x equals x cubed plus x squared minus 5x plus 3. Which means if x minus 1 is a factor, I must substitute f of 1. And that will give me 1 cubed. And I'm sure you can do the rest completely all on your own, plus 3. That is simple. That is 1 plus 1 minus 5 plus 3. 2 plus 3 is 5, minus 5 is 0. Yes, I've got him. That implies that x minus 1 is a factor. I'm done with that. Let's have a look further on my screen. Can you see I started it for you? And therefore, x minus 1 is a factor. Let's continue. Question 2. They ask me to factorize completely. Now look how question 1 helped me to get to 1.2, because the one factor is given. Your only problem is to find out what should be under this little green block here. And from I know up to this stage, all of you use different methods. And I need to say that it doesn't matter whether you use long division, synthetic division, or you compare the coefficients. They will all give you the same answer. So let's work it out together and then see how we fare with it. I still prefer the synthetic division method, but I know all of you don't use this method. Remember, you must use the method that you are comfortable with, the method your teacher has been using up to this stage. Don't try any fancy new tricks at this point in time. Okay, my equation is there. Right, on my page, I've got f of x equals x cubed minus x squared minus 5x plus 3. I know that x minus 1 is a factor. I need to find the partner. So I'm going to do it the one method first and then switch over to my synthetic division, my favorite. Okay, how do we get the first term? We know that the first term should be something like x cubed divided by x, so that will give me x squared. And if I look at my last term, I would have 3 divided by minus 1, and that will give me minus 3. Okay, but somewhere here in the middle should be something else, that middle term. So that middle term, let's say it is kx. And I'm just using this. Remember, your method works. Kx. We are going to find out what is that kx. Now, kx is the coefficient of x. So I'm going to multiply out these terms and see which of these terms will give me a term in x. Okay. That gives me, this times this gives me x squared. This times this gives me x squared as well. This times this gives me an x squared. But this times this gives me minus kx. Now I'm taking the next one. That times that give me minus 3x. And I know that these two together must be the same as that coefficient there. So I'm looking in terms of all my x's. So that should give me that 5x. We know if I take out common factors here, then I can basically just get rid of all those x's by making use of common factors. So minus k minus 3 is equal to minus 5. So minus k will be equal to, you're right, and k must be equal to 2. So my missing one there becomes x minus 1 times x squared plus 2x minus 3. I know many of you are using this method. My good old favorite goes like this. I write down the coefficient of the original one. So it's 1, 1, minus 5 plus 3. My divisor, I'm going to put in this little block which is 1. And the rule tells me the first one, I'm going to bring him down. And then I'm going to multiply. 1 times 1 gives me 1. And I add. That gives me 2. This times this gives me plus 2. If I add, I get minus 3. And this times this gives me minus 3. And if I add, I get 0. There's my remainder. What does this become? This is my x squared, and that's my x. So my two terms becomes x minus 1 in x squared plus 2x minus 3. Both methods brings me to the same point. Long division will do exactly the same thing, but please people, use what you are comfortable with. So back to my screen. Right, that is what I said earlier. That gives me that 2x that I've just calculated with you. And this is a quadratic equation. That you can all factorize, and I end up with that. Please note, at this stage, you should know, I notice I've got two factors that's exactly the same, which tells me that my graph will be touching my x-axis because I have two equal roots, which means my graph will touch the x-axis at some point. Question number 3, 1.3. Determine the x and the y intercepts of f of x. I'm sure everybody knows that. The x-intercept, let's start with the y-intercept first. The y-intercept, then x equals 0. So I end up with 0, 0, 0 plus 3. Y equals 3. That's no problem. But my x-intercept, then x equals 0. Remember 1.2? We worked out these factors already. Please do not waste your time now. So I have, there's my factors, equals 0. So x equals 1 or x equals minus 3. 1 minute just for you to, not even less than 1 minute, just to get up to date with me so that I don't run too far away from where you are working. I'm sure you should be ready. Question number 1.4. You can see I've got brains there, and my brain's sparking, because I'm sure you know that if they ask me for the turning points, then it means the derivative equals 0. The derivative equals 0. So, let's start. The derivative. Let's work out our derivative quickly. Right. My graph is given, and I'm working through this, so just to refresh your memory after a very long break. If I want the derivative, the rule is the top number, I bring him down, so it becomes 3x to the power 1 less. Minus, plus, the top comes down, which gives me 2x to the power 1 less. And there is a 1 at the top, so it becomes 5 to the power 1 less gives me 0. So my derivative becomes 3x squared plus 2x minus 5, and there's my derivative. But we know, if we come back to my screen, the derivative must be equal to 0. So that derivative, I'm making him equal to 0. And all I need to do is I need to solve for x. Quadratic. You factorize and compare your answers with what you see on the screen quickly. It's a plain and simple quadratic equation. Okay. And if you're still using the formula to find that, you still have time to practice how to factorize properly. But I never answered the question. If I just go back one slide, the question was, determine the coordinates. These are not coordinates. And if you don't give the examiner the coordinates, they're not going to give you full marks. So therefore, the coordinates mean that I must now substitute these values into the original equation. Can you see there? Oh, I made an error there. That should be minus there. But if I work it out, that should be your answer. Calculator. Don't need to break your necks about all these funny fractions coming up. Use the calculator and your answer will be there. And then, my one coordinate will be minus 5 over 3 and 256 over 27 or 9 over 13. But the other coordinate, I know that x was 1. And because I had two factors, I don't even need to work this out because I know my turning point must be on that x-axis. So I can just write that down and I can feel I did not waste unnecessary time to get these two answers in place. Okay, so we have the coordinates in place and we can now move on. The next point, 1.5, they ask us, determine the x value of the point of intersection. It's a point. Right. And what do we know about the point of intersection? Obviously, we said that the second derivative equals 0. So that is why on the screen I have the derivative written down, which is f prime of x equals 3x squared plus 2x minus 5. My second derivative means I must get the derivative from this one. So f double prime of x becomes, yes, to the power 1. And this becomes 2. And we further know that this derivative, 6x plus 2, must be equal to 0 because they want the x value. So 6x will be equal to minus 2 and x becomes minus 2 over 6, which is the same as minus 1/3. Oh, more points in your pocket. Back to my screen and let's see. I have all the information that they want me to have. I do have the y-intercept. I do have the x-intercept. I did use the factor theorem. I do have the turning points because I worked out where the derivative was 0. All I need to do now is to sketch my graph. So at this point, I want you to draw your axes and then we can draw our graph together. Draw your axes. You've got 1 minute, half a minute to draw the axis very quickly. And then we can draw our graph together. Good people. Remember, we don't need to work very neat today. We will do everything very quick and very rough because when you go home this afternoon, you are going to see how much can you remember of these problems and you will try to do all these problems from scratch. So, what was the main things that we discovered? If I come back on my screen, we know my x-intercepts. Oh, I remember them. They were there at minus 1, and that one I know was there at 3. Right. I know that I had two factors here, so I know my graphs must do that there. My minimum turning point, sorry, I'm working upside down. My maximum turning point there was that one there. So if I draw my graph in, and that should cut there at 3. Please fill in all your values. I'm going to quickly flash back on my slides just so that you can see where my coordinates were. My x-intercepts was at -3 and at 1. And that happened there at 3. Okay. And my turning point was, the coordinates of my turning point was the one -5 over 3 and 9 over and 13 over 27. And this one here was the 1 and 0, that point there. So now we have our graph, and if we continue and look at the more difficult questions that's coming up now. The difficult questions that are coming up are the ones where people normally have the most problem with. For which values of x is f of x increasing? Where is this graph, the values of x increasing? So, if I look at this, the values of x increasing. So if I look at this, it is the values of x is increasing on that side and it's increasing on this side here. Let me use a different color. That little piece and that little piece. That's where the values, for which values of x is f of x increasing. The y values are increasing in those bits. And because we have two separate sections, we need to know where does this start on my x-axis. So as you can see, it starts at x, all values of x less than -5 over 3. That's my one section. My other section will be that little piece there. In other words, it starts here and it moves that way. Therefore, x greater than 1. And there you have him. My advice to you is shade it with your color pen or with your pencil on your graph, and then remember, if they ask for the values of x, then your answer can only be on the x-axis. So you read the first value off on the x-axis and you try to establish where it's going to, and you should be able to write down your answer. So that is now my first one. Your 1.8 on the screen or in your booklet tells you, describe one transformation of f of x for which will result in f of x having two unequal positive roots. Two unequal positive roots. So let's have a look at my sketch once again. Let's have a look down on my page. This is my sketch. This root here is a positive root and this one here is a negative root. I want two unequal positive roots. In other words, you'll agree with me, if I can push this graph that way, then little bit over this line, then this point will move on and I will have two positive roots. So what transformation do we have in mind? We can say the transformation is a shift to the right. How many units to the right? How many units do I have here? You'll agree with me, I have 3 units there. So I will have to move this graph more than 3 units in order to get 2 positive real roots. Okay? Please look at the picture. I'll repeat what I've said. I've got a positive and a negative. I want this one also to be positive. A transformation means a shift. The only way I can do it, I must shift him more than 3 units to the right in order to get 2 positive roots. And that you need to write out in words because they are telling you to describe. That's my word. It's not a mathematical sentence that I'm going to write down. Okay. Now, before I finish off with this particular problem, I want us to look at this graph very carefully. I have my curve, right? Because I'm going to need this information later. I have my curve. And I also know that my derivative of my curve, the derivative of this cubic function, was a parabola. It was a quadratic equation. If I remember correctly, my equation was 3x squared plus 2x plus 5. And if I add this to my sketch, then my graph will do something like this. It's a parabola that will cut there, and it will do something like that. What is important to note, that my turning point, at this point, my derivative was 0. And if I look at my derivative now, then my derivative, as you can see, it is 0 there as well. And it's the same happens at that point where my derivative is 0. So when I look at the derivative, which is that parabola, and I read off my y values, then you can see it will be my y derivative was positive, 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 and then it's 0, and then it becomes negative, negative, negative. So at this turning point, the derivative was first positive, then 0, and then it's below, so therefore it was negative. If I look at this point, the gradient was positive, and then 0, and then negative. So this derivative function tells me what my turning point will be like. Okay, keep this in mind because I would like to come back to the sketch when we do our next example. Okay, my next problem asks me 1.9. Ask me, determine the equation of the tangent. Remember, I warned you about the tangent. Where f of x, where x equals -2. What did we say? Right, remember my first slide? We said substitute x into the derivative to find m. Okay, so let's do that together. My derivative, you should have him in front of you. your derivative was f of x equals 3x squared plus 2x plus 5. Okay, x is minus 2. So f prime of minus 2 will become 3 times. You can continue on your own while I'm writing. Uh-oh. Right? Are we all good? Let's compare. 3 times 4 plus 2. I'm sorry, that was minus 5 there. Oh, I can make such a lot of stupid errors at time. That was minus 5. So that is minus. So you have 12 minus 9, which will give me 3. So my gradient is 3. So, what did I mean when I said use the point to find C? So what I have now is that I know that y equals 3x plus c. If I can find one point on that graph, then, and I substitute that point, then C will pop out fairly easy. And we did this a lot when we do the parabola. So it is nothing new. It's the same type of calculation that we did. We just need to have a look at our graph once again. Okay, so let's have a look at my graph. There's my graph. I want the gradient where x is minus 2. It's somewhere there. I want the gradient at that point. Can you find one nice point? Oh, I like him. Where x is 1, then y is 0. When x is 1 and y is 0. So, it will give me 3 times 1 plus c equals 0. So that will give me therefore my equation of my tangent becomes y equals 3x minus 3. Okay. The last part, they ask me, prove that the tangent in my equation will cut the curve in 2 places. Anywhere where a line cuts a curve, it implies simultaneous equations. So you need to work on simultaneous equations. Okay, I'm not going to work that out because I feel that is old work and you can battle with that completely on your own.